Module 4.1, Harmonics, Overtones, Partials, and Octaves. So we spoke about the fundamental frequency being the lowest resonant frequency of a vibrating system. And we refer to that as F1. We then said that a harmonic is another resonant frequency that is an integer multiple of the fundamental frequency. Now, it turns out that when we listen to sounds, it's very rare that we only hear a single tone. It's not something that we tend to listen to, and it's not the way most sounds are made. Most sounds, it turns out, are made up of a wide variety of sounds, and they all happen together. So for some sounds, and we'll learn about this soon, like string instruments or brass instruments, you'll have the fundamental frequency and then many harmonics that lead up to that. So the combination of all of the different frequencies that make up a sound are called partials. I like to make this similar to a recipe for food. For example, if you're making pasta sauce, you're going to put in tomatoes and onions and garlic and some basil, a little sugar, a little wine, some oregano, some thyme, and you mix it up and you cook it up and it makes a nice pasta sauce. If you have a trumpet sound, you're going to have a fundamental and a certain number of harmonics. A saxophone or a flute will have a fundamental and a different set of harmonics. So just the same as if you make a pasta sauce, it may have some of the same ingredients as mine. It may have some different ones, and the proportions will be different. So your pasta sauce will taste different from my pasta sauce. They're both pasta sauces. If we hear a clarinet or a flute play a certain note, we'll hear that they're different because of the combination of frequencies is different. And again, these different frequencies are all called partials. There's another term that we need to learn, and that's called overtones. And this is all of the frequencies except for the fundamental. Now, it turns out some sounds are made up of a fundamental and harmonics, or we could say the fundamental and overtones, and some are made up of a fundamental sound and a lot of other frequencies that are not harmonically related. That means they are other frequencies, but they are not integer multiples of the sounds. They are still considered overtones, but they would be called non-harmonic overtones. And we will look at things like that later. But for example, the sound that a drum makes, or a cymbal, or the air conditioning, or a church bell, those all have sounds that are not harmonic included with a fundamental sound. Finally, we have another term that is called octaves. Octaves are a special form of sounds, and they are frequencies that are either double or half of another frequency. So octave, you know, means 8. We'll talk about why octave is a doubling when we talk about musical notes and scales. But right now, we just need to understand that an octave is a doubling or a halving of frequencies. So let's look at some numbers so that we understand these, and then we'll listen to some of these as well. So let us say, so that the math is nice and easy, that our fundamental frequency, F1, is 100 hertz. All right, so that's our fundamental. Then F2 would be 200 hertz. That's the second harmonic. F3 would be 300 hertz, and that's the third harmonic. Let's do F4, F5, F6, F7, and F8. So all of these would be considered overtones. And all of them are harmonics. However, 200 to 100 is one octave. 100 to 400 is two octaves. Or this would be one octave because 200 to 400 is a doubling. 100 to 200 is one octave. This is one octave. Then this is two octaves. And then, so let's call this one octave. Get rid of this guy for confusion's sake. And this would be an octave. An octave is a range, not a frequency. So we can't say 800 hertz is an octave. 400 to 800 hertz is an octave. 200 to 100 is an octave. All right, but a certain frequency is not an octave. It would be an octave above or an octave below. Octaves are harmonics, but not all harmonics are octaves. So 300 hertz is not an octave. It is a harmonic. It is an overtone. All of these frequencies are partials. So we have two formulas. We already talked about for any harmonic, f to the n equals n times f1. If you want to know what note is a certain octave above or below a note, you can use this, where we're going to say f of the number octave equals 2 to the n times f1. So for example, if we wanted to know what note was 2 octaves above 100, n is the harmonic number, is the octave number, so 2 to the second equals 4, f1 is times 100, and that would be 400. So 400 hertz is 2 octaves above 100 hertz. 1 octave, 2 octaves. To review, the fundamental frequency is the lowest resonant frequency of a system. A harmonic is an integer multiple of the fundamental frequency. To find any harmonic, f to the n equals n times f1, where n is the harmonic number. Partials are all of the frequencies that make up a sound. Overtones are all of the frequencies that make up a sound except for the fundamental. An octave is a doubling or halving of frequency. To find the frequency that is a certain number of octaves above or below, f to the n equals 2 to the n times f1, where n is the number of octaves above or below. For octaves below, n will be a negative number.